Okay, example 5. What do the average rates of change over the intervals -2, 0, 0, 3, and -2, 3 indicate about the given function? So again, when it's talking about intervals, these are all x values, from -2 to 0. So I'm going to do this first one in red. So x equals -2 to x equals 0. That's what that interval means. Okay, the brackets mean we're including -2 and 0. Average rate of change is simply asking how much did it change and how long did it take to change. Okay. So, if I'm looking at the function f of x equals 1, all right, if I'm asked this rate of change question and the function's f of x equals 1, and my interval goes from -2 to 0, it simply wants me to evaluate. So x equals -2, x equals 0. Now, I want to bring to your attention what this function is, f of x equals 1. It's called a constant function. What I want you to recognize about a constant function, what you should see, what your eyes should see when you look at this, is the f of x, the function notation, equals a number. It doesn't equal x. There's no x's over on that side. That's what a constant function is. It's going to be function equals some number. Okay? All that's saying is no matter what x equals, the answer is 1. That's what a constant function means. I don't care what x is, the answer is 1. So when x is -2, what's the answer? 1. When x is 0, what's the answer? 1. That's all a constant function. That's how you evaluate a constant function. The answer is always that number. If it said f of x equals 17, the answer is always 17.
How do you know it's a constant function?
Because there's no x. F of x equals no x. Hello? I think 14, maybe 17.
14.
Tomorrow? Seventh period. That's algebra 2. No. None of those are golfers. Yes. Thanks. So the way we recognize a constant function, functional structure, f of x, g of x, h of x, one of these things equals just a number. No x's. That has an x, not constant. That has an x, not constant. That doesn't constant. And when that happens again, the answer is just that number. All right, so f of x equals number, answers the number. So rate of change is simply how much does this change on top? How much does this change on the bottom? Top, bottom. Change is subtraction. We subtract. The only requirement of subtraction is we subtract the same order. So I'm going to do this number minus that number. So I'm going to do, on top I'm going to go 1 minus 1. And just to clarify which one I'm talking about. But I did that one minus that one on top. So on the bottom, I've got to do this first. So -2 and then minus 0. That's how you find the rate of change. The y value minus the y value on top, x minus x on the bottom. So 1 minus 1 is 0. -2 minus 0 is -2. 0 divided by -2 is 0. So rate of change, average rate of change of the first function from -2 to 0 is 0. Continuing on, I'm going to go with the second interval, same function here. So 0, 3 is my second interval, right? So I'm still using this function here, still a constant function. I'm going to put x, f of x. What two numbers am I going to put in the x column? 3 and 0, right? The numbers in our interval, right? So x equals 0 to x equals 3. f of x equals 1, constant function. So that means the answer is 1 no matter what x equals. So if x is 0, the answer is? If x is 3, the answer is 1. All right? So again, I'm going to do that minus that, that minus that. So it's going to be 1 minus 1 on top, 0 minus 3 on the bottom. That gets me 0 over negative 3, which equals 0. Are you noticing a pattern here with this function? A constant function, the answer is always 1. So no matter what x is, I'm moving along the x-axis here. I'm here, I go up to 1. I'm here, I go up to 1. I'm here, I go up to 1. I just keep on getting the same answer all the way along. It doesn't change. It doesn't go up, it doesn't go down, it stays the same, right? Average rate of change is just how much does it change. So on this last interval, negative 2 to 3, x f of x, I'm going to put negative 2 and 3 over here, right? Negative 2, comma 1, positive 3, comma 1. Again, it's still using the same function. The answer is always 1 no matter what x is. I'm going to subtract this one, and I'm going to subtract that order. So on top, I'm going to get 1 minus 1. On the bottom, I'm going to get negative 2 minus 3. That gets me 0 over negative 5, which equals 0. So the average rates of change of f of x on all three intervals is 0. As far as how to answer it, how to write your answer on this, what we're finding here is actually called slope. We're not necessarily finding the slope of the equation, we're finding the slope from this point to that point. Sometimes the curves do weird things and it's not really a slope of the curve itself. All right? Is everybody comfortable with part A?
Do we always subtract?
Always, yeah. But once you get the points in here, once you get your values, it's 1 minus the other, 1 minus the other. It doesn't matter. I could have done this minus this, that minus that also. It doesn't matter what order you go, just the same. So just make sure you go in the same order. Okay, so I'm going to grab all this and make it small so I have room to work. Move on to part B. Part B, we're going to be using function g of x. So again, I'm using the interval negative 2 to 0 first. My function is g of x equals 1/2 x minus 1. And if I do an x comma g of x function structure here, all right, this one's a little bit harder to evaluate, so I'm going to actually make a third column for this one. 1/2 x minus 1 g of x. All right. So my first interval goes from x equals negative 2 to x equals 0. Again, it doesn't matter which one's which, just make sure they're both there. If I'm trying to find the average rate of change from something to something, I want those two numbers to be the numbers I picked. All right? For me personally, I'm going to do half the number in my head. What's half of negative 2? Negative 1. So I'm going to negative 1 minus 1. What's half of 0? 0, so 0 minus 1, right? So the 1/2 of x, I'm just doing that in my head to write it down, then the minus 1 happens afterwards. Negative 1 minus 1 is negative 2, 0 minus 1 is negative 1. So again, I subtract. I'm going to do this subtraction on top, I'm going to do this subtraction on the bottom. So let's see what happens. On top, I'm going to get negative 2 minus negative 1. On the bottom, I get negative 2 minus 0. The first one minus the second one on top, the first one minus the second one on the bottom. And you can see minus 1 here makes plus 1, so that's negative 1 over negative 2, which is positive 1/2. The second interval takes us from 0 to 3. All right, so again, if I make an x chart here, x, 1/2 x minus 1, and g of x. Okay, I'm going from 0 to 3, so 0 and 3. And half of 0 is 0, minus 1. Half of 3 is 3 halves, right? 3 halves. Now watch what I do here. I'm going to say minus 2 halves. If I get a fraction in my structure, I want everything to have a common denominator. So I went ahead and said 1 is equal to 2 over 2. All right, so 0 minus 1 is negative 1. 3 halves minus 2 halves is 1 half.
On A
Yep.
is, right in the parentheses for the answer, what is that?
For A.
See the parentheses on the bottom where our equation is down?
Like down here.
Yeah.
That's plus plus.
Okay.
It was minus minus. I made it a plus plus.
Oh.
All right. So again, I subtract. So I'm going to have this minus this. So that's going to be negative 1 minus 1 half. On the bottom, I get 0 minus 3. First minus second on top, first minus second on the bottom. So I get on top minus 1 is minus 2 halves, right? So again, just using just basic subtraction of fractions technique, common denominator. So I got basically negative 2 halves minus 1 half over 0 minus 3, which is negative 3, right? What does minus 2 halves and minus 1 half make?
1 half.
Should we add or subtract? It says minus, right? But look at the signs of the things involved in the problem. Should we add or subtract the numbers? We're going to add because the signs are both negative, right? So 3 halves, and then they're both negative, so negative 3 halves. Okay, so negative 3 halves over negative 3. Keep in mind that a fraction is just a division problem. So it's top divided by bottom. I made the bottom into a fraction. We make it into reciprocal multiplication. So negative 3 halves times 1/3. Negative 1/3 makes positive. 3's cancel, so it's going to be 1 half. All right, our final interval goes from negative 2 to 3. Okay, so we got x equals something. We got 1 half x minus 1, and we have g of x. So x is going to be negative 2 and 3 for this one, right? Again, that's my interval starting at negative 2, ending at 3. I'm going to do 1 half of negative 2 is negative 1, so negative 1 minus 1. And then 3 halves minus 2 halves makes 1 half. There we go. So on top, I'm going to have negative 2 minus 1 half. On the bottom, I'm going to have negative 2 minus 3. So negative 2 minus 1 half over negative 2 minus 3.
Why aren't we doing x squared for this?
Because we're doing, that's part C, we're still on part B.
Oh.
We have interval 1, interval
Oh, yeah.
2, interval 3, right? We have 3 different intervals for each one. So, negative 2 is negative 4 halves, right? Same as negative 2. So on top I get negative 4 halves minus 1 half is negative 5 halves. Negative 2 minus 3 on the bottom is negative 5. And again, just like the other one, it's negative 5 halves divided by negative 5 over 1, which is negative 5 halves times negative 1/5. 2 negatives make a positive. 5 divided by 5 cancels, so we get positive 1 half. So for part B, it looks like 1 half is the answer to all 3 of them, right? So this equals 1 half also. So the average rate of change for part B, all 3 intervals, is positive 1 half. So for part B, if I write my answer over here, the slope from negative 2 to 0, rate of change is going to be positive 1 half. Average rate of change from 0 to 3 is positive 1 half. Average rate of change from 0 to 3 is positive 1 half. I'm going to take all this work, make it small so it gets out of the way. All right, our final one. We got h of x equals x squared, and we got interval from -2 to 0. So if I make up an xy chart for this, I got my x, I got my x squared, and I got my h of x. So -2 to 0, I'm worried about -2, I'm worried about 0. So here I've got -2 squared, here I've got 0 squared. All right, so x is being squared. Make sure the sign and the number all get squared, don't just square the number. So when I have -2 times -2 makes +4, 0 times 0 makes 0. So if we consider the subtraction of those numbers in that order, subtraction of those numbers in that order, that's going to be 4 minus 0 on top, -2 minus 0 on the bottom. 4 minus 0 is 4, -2 minus 0 is -2, that divides to -2. So the average rate of change for -2 to 0 for h of x equals x squared is -2. My second interval, 0 to 3, so now I'm going to have x squared h of x. I'm going to put 0 and 3 in. We already know 0 squared equals 0, 3 squared equals 9, right? So I'm going from here to here, so it's going to be that minus that, so 0 minus 9 on top, 0 minus 3 on the bottom. It gets me 9 over 3, which equals +3. Notice the other two functions, same. Now we got -2, +3, right? And then finally, the last interval, -2 to 3. Once again, -2 squared is still +4, 3 squared is still +9. If I do this subtraction, 4 minus 9 on top, and I do this subtraction, -2 minus 3 on the bottom, I get -5 on top, -5 on the bottom, which is +1. So, if I write those down, in part C, m bar from -2 to 0 equals -2, m bar from 0 to 3 is equal to +3, m bar from -2 to 3 equals +1. What does it indicate about the given functions? Okay, for me, the 0 means it's constant, it's flat. Everything's 1/2 means it's always going up 1/2. So it's slanted, but it's always going up, right? This one goes down to 0, goes up to 3, it goes up from -2 to 3. So if I'm looking at this, just looking at these 3 points, -2, 4, let's put 4 here. Then we have 0, 0, then we have 3, 9, right? Let's put 9 up here. Looks like it goes down, then it goes up. So from here to here it's going down, there to there it's going up, and from here to here it's going up also. It's not in a straight line. So that the variable change of our rate of change there tells me that it's changing. There's probably some curvature to it usually when that happens. All right.